Alright, I'm pretty much done with most of my work on this printer that I think I'm about ready to start actually printing the things I wanted to print. I did this test for my neighbor for this mousetrap thing he wanted me to build, and that worked out great. So one thing I do want to add though is I'm finding I'm constantly burning through my hot end fans because I'll start something printing and then I'll leave it printing either during the day when I'm at work or overnight, and the print's done and it's still spinning away doing nothing. So I'm gonna make a mod to this that I've always wanted to do, and I have the opportunity to do that now because of this. This is a solid state relay. Opto 22 is another part that was getting tossed out at work, and I said, hey, don't do that. I can use that. So this is a 3 to 32 volt DC input and a 3 amp output. And this is more than fine for what I want to use here. Physically, it's overkill, it's huge, but I don't care because I'm upcycling something that was getting thrown into a landfill, so who cares? So if I go online and look up the specs for this solid state relay, it's pretty common, pretty easy to find, and let's see if I can find this here. Switching specifications. So what it's telling me is that my signal input impedance for my input pins for the 60S3, which is what I have, and all of them really, is 1000 ohms. So if I have 5 volts coming from my output pin on my Arduino and divide that by 1000 ohms, that's going to pull 5 milliamps from my Arduino or my ramps pin. So if I go and look at my Atmel processor and I scroll through, I don't know, 350 some pages of specifications, it tells me that my DC current output per IO pin is 40 milliamps. So I'm well within my limits to run this relay directly. If it's only going to draw 5 milliamps and the most it can put out is 40, the most I can put out altogether through all my pins is 200. I don't think I'm going to hit that at all. I guess we'll find out, won't we? So on my ramps board itself, you have AUX 1 and AUX 2 and AUX 3. You've got some auxiliary pins here that you can use for different outputs besides what are already being used for the ramps or the stepper drivers and all the other functions here. So if I scooch over to a diagram of this, and I ended up just using the AUX 2 pin here, and that pin has voltage, it's got ground on pin 2, and I used pin D42, which is pin 8 here, to drive my solid state relay. I used D42 because it's the same G code. If I scroll down here to M42, right here, M42 is to switch my IO pin. So I just have to send a command M42, and then P is the pin number, and then S is the set point value you're sending to that. And this is just a digital pin, it's not pulse width modulated, so I can either turn it on or off, which is fine. I just want this fan to be on or off. So M42, P42, S255 will turn this on. I used pin 42 because it was the same as the M code and I could remember it easy. All I need to do is connect pin 42 to the positive of the relay here and connect pin 4 to ground. And there was both a ground and right on the same AUX 2 connector with that pin 42, so I just need to make a connector to connect to those 2 pins, and then the output here is just like a relay contact, so I have to put positive on this side, and I can pull my 12 volts from my main 12 volt bus that comes in here, and the other side I will connect to the wire that goes to the fan itself. So there's my AUX 2 with my black is connected to the ground and the red is connected to pin 42, and that goes directly down to my solid state relay here. Red is positive, black is ground. And I've got my green wire connected to my 12 volts on the bus, and my white wire connected to the wire that goes to the positive of the fan. I have to enter an M42 and pin 42 and S255. Actually, anything over 128 will work, but 255. And my fan comes on. Wow, that's just brilliant science. And I can just send a S0, M42, P42, S0 to turn that off again. Alright, just for fun, I mounted it to the frame. I guess that's not fun, that's actually pretty practical. And I also added an LED and a resistor to the input, just as a visual indicator that the fan is on, to remind me that it comes on. So now I have to actually change the Arduino code so that the fan will turn on and off depending on the hot end temperature. So if you go into your Marlin software, typically you make most of your changes in the configuration.h file. This one is in the configuration advanced file. So if you do a Control F to search, and search for auto_fan, and that will quickly take you to the section that this controls. So you can read this all you want, but the short answer is my extruder 0 auto fan. If it's set to -1, then it doesn't control anything. So my fan pin is 42 as previously specified, and I'm going to set this to 70 degrees. Anything below 70, I'm not likely to destroy my extruder from melted plastic, so that's fine. I'm going to leave that to 255 for my fan speed because I want it to spin full speed all the time. Alright, so once those changes have been made, then you just click the arrow in the top left corner to compile your sketch and then upload it to your Arduino. Okay, uploading a successful compile. Alright, so if I set my temp to turn on, as soon as that gets above 70, then my fan will kick on by itself. So there I go. So now I don't ever have to worry about leaving my printer on all night or all day when I'm at work, and I don't have to worry about the fan shutting off when it gets cold enough or not being on when it's hot enough. That's happened before. It's a pretty good mod, I guess, and I'm reusing something that was going to get thrown away, and so I always feel good about that.